In this section related to Unit 2, we'll talk about modeling and decision making in GIS. Few things cause more consternation and confusion among students, and thus annoyance among professors, than the topic of modeling and models in GIS. The first thing that I want you to remember is that there's a huge difference between data models, which you've learned about, i.e. the vector and raster data models, and the process of model building. They're two completely different things, which unfortunately have a similar name. Now, the reason they have a similar name is that vector and raster data models do the same thing that other models do, and that is that they provide a simplified representation of reality. Vector data models are object-related, and they show us how the world can be simplified and represented through vector data, and raster models show us continuous data and how that data can be represented through grid cells. But again, the concept of a data model is completely different from modeling in GIS. So for now, put raster and vector out of your mind and turn your attention to this concept of modeling. A good introduction to GIS and modeling is provided by Michael Goodchild, and the link is right here on the page. Modeling can be defined in the context of geographic information systems as occurring whenever operations of the GIS attempt to emulate processes in the real world at one point in time or over an extended period. In other words, we typically will take GIS data, different categories of variables or attributes, if you will. Sometimes they come from various feature classes and various sources, and they might have various different kinds of formats. We take that data and we put it together, and GIS modeling allows us to combine variables in order to get a result. So here are a couple of examples. If I draw your attention to the biggest one first, which just shows you the concept of a model that might work in terms of processes in a business. These are all the factors that have to be taken into account when you're looking at various factors for the business. So from the customer point of view, the customer is paying bills, hopefully, and that goes through accounts management and capital management. And then you have maintenance and purchasing and collections and production planning and quality assurance, and all of these things become factors that represent either supporting or core roles in the business model. GIS modeling is somewhat similar in the sense that you have to weigh and understand ways of building models based on the impact and role of data on your output. So for example, in the business process development steps in the lower left-hand corner, the initial definition, identify processes and create a process team and identify the requirements, and then detailed definitions and software and development and pilot the thing, and then what's your final production. So all those factors have to be taken into account. And based on the material in the previous lecture, you should be aware that you're building your own research and your own work in GIS in kind of a step-by-step way. And you can kind of substitute your own context for how you do things in terms of research on the whole, for now applying it to a model itself. So for example, these are generic models that show us the way that this would appear in ArcGIS in Model Builder. Modeling itself is a broad category. Model Builder is a set of tools that relates to GIS specifically. So for example, this shows you process and it shows you data that can be put together to create output. So first of all, the one on the right, we use a cadastral map feature data set. We create topology, which means that we have to define the ways in which the objects in this feature data set relate to one another. And so we create that topology. We apply it to the model. We add other input objects. And eventually, we do things like we would add parcels and buildings and rules of topology and get output as a result. Another way to look at it in terms of generic models is to say, well, we're going to take data and put it into a system, and then we're going to do something to it. We show that up in the upper left corner here. We take points, we iterate feature selections, we then look at a selected number of points. Kriging is a method of analysis, and then we get a result out of that after doing that. Here's some specific models. This really kind of makes it much more tangible. So this shows a forest access model. A map of slope is used to establish relative and absolute barriers for operating mechanized harvesting equipment. So if you were going to go for forest management and want to know what would be the areas you could bring in what kind of equipment. This includes maps of ownership, water, and sensitive areas. They're used to establish additional barriers based on legal constraints. So you'd have to first of all identify what are the major factors at hand here. In this case, this model has 5 different variables that are looked at initially: slope, ownership, water, sensitive area definition, and watershed conditions. And so you then basically analyze each of these factors and their relationship to one another so that you come out with an indicator that shows you which land has an impedance due to slope, which land is unavailable due to ownership, where do you have stream buffers so you can't operate equipment, where do you have protected areas. And from that, you can then create a cost surface, which is basically a result of the model that tells you feasibly where can you operate this equipment. And then the important factor is, are there roads there? And are you going to have to build roads? That affects things. And the result in the end shows you where you can and cannot bring in mechanized equipment to these forest areas. Now, this is very important because it helps people make decisions. It helps you make decisions about a process from an environmental point of view that takes into account the different factors you have to think about. You don't want your employer to get sued. You don't want to piss off the neighbors. You don't want to violate regulations, hopefully. You want to recognize the importance of things like slope that can cause problems of erosion, or maybe problems just in getting your equipment in there, that can add time to the employees, that can do all kinds of things. It can be dangerous. There are all kinds of factors that come in here. And so you can see how a model can be an effective way to help people make decisions. Here's a much more complicated model, but one that some of you will identify with quite well, I think. U.S. areas with best conditions for opening a new brewery or winery. In the initial layer, we want to look at several things. Drunk driving fatalities per capita. We don't want to locate this in a place where we know people are going to drink and drive and kill themselves or other people. You want to be somewhere near a market, so you're in an urban area. What are the beer and excise taxes? What are the distribution laws? This varies a great deal by state. What are the wine taxes? What are the breweries per capita already? What's your competition, in other words? Or do you benefit from being in a place where there's a lot of breweries, so there's a culture of going into breweries or wineries? And then, do you have important temperatures? So, for example, you need to grow wine grapes. Well, you're better off doing that in places that have the right kind of climate conditions and so on. And so you have to look at these attributes and you model multiple factors then in various steps. And you want to look at how these things intersect. So you've got your urban areas and you've got your patterns of public opinion. How do they intersect? How does that help you narrow down potential locations? Do you have favorable taxes? Do the state laws allow self-distribution? Do you have favorable conditions in terms of the market, or is it already a saturated market? What's the economic condition? And in the end, you basically create an intersect, and from that, you identify prime locations for a new winery or a new brewery. In the next section, we'll take a look at some decision-making processes from spatial analysis. First of all, the level of understanding. This is very important, and it goes back to your awareness of the situation at hand and of the topic you're looking at. So first of all, understanding how does your analysis apply to the problem. Does it provide awareness or information or solution? How do you recognize those factors? What kind of information do you need? What kind of data do you need? How do you evaluate alternatives? Impacts. How will others interpret your output? Is there more information that needs to be presented with this analysis so others better understand? Does the analysis completely solve the initial problem? Is it more than what they wanted? One of our biggest problems is that in GIS there's almost no limit to what we can do. So it's very important to define yourself in a way that is relevant to the user. You can always go back later and add more. Avoid chasing the shiny objects again. You don't want to end up with that raccoon with a collection of spoons. You want to be doing the things that you need to do in order to get the job done. And finally, what about the needs? So you've done some analysis, you have a plan, but is there more that's needed? We talked a little bit before about how you don't want to do more than is needed, but are you actually addressing at a minimal level what's needed? And what do you do when the analysis raises more questions? Maybe they need to be addressed, maybe they don't. And what other resources might be needed? So there are all kinds of factors that come in here, and the resources are really critical to this whole thing because you've got to worry about funding. You have to worry about people. Do you have the right people? Do the people have the time to do that work? Are they budgeted the right way? Do you have the right facilities? Does your technology meet the needs? What about data and resources and other factors? Those are all important factors that come into this. Now, you can't solve all this in Geography 2700. Keep in mind that underlying much of this look at how we kind of make decisions and do analysis is dealt with in our capstone course. You deal with it several different ways in different courses throughout the GIS program, but in the capstone course, which is the project management class, you really grapple with all these factors as if you're a project manager, and you learn how to do it at that point. So don't be overwhelmed by all these factors that come into making decisions, because you could sit here all day and scratch your head and never get anything done. But it's very important that you develop an awareness of the complexity so that you don't just forge ahead and make maps that then aren't useful because you haven't considered the factors that go into it. All right, that concludes this section.